Alright, so today we're going to start dealing with polynomials of higher degrees. Okay, so first of all, who remembers what a polynomial is?
Multiple terms.
Multiple terms. What do you mean?
Like x squared plus x plus
So would you say then a polynomial has multiple monomials, right, of different degrees, correct? So polynomials, you typically want to keep them in order from highest degree to lowest degree, correct? Alright, so one of the characteristics that you need to remember about polynomials, it is that it is continuous. Okay, what does it mean to be continuous? It never breaks, there's no holes, there's no gaps. So in other words, when you're sketching this, your pencil should never leave the page. Okay, that's what's going to tell you that it's continuous. If you have to take, that means that it is non-continuous. Another characteristic is that it has very smooth curves. In other words, it has no concavity. So what does it mean to be concave? You will not have any sharp turns. Okay, it's very smooth, rounded turns. Okay, so keep that in mind when you're sketching this, because we are going to be sketching a lot of this. Alright, so what we're going to do today basically is we are going to be sketching this, and I am going to give you tools to help you come up with sketches. Okay, when I say sketch, I literally mean sketch. I don't want perfect graphs. Okay, if I want a perfect graph, then I would have you find a lot of points at this moment. Okay, but here's what's going to happen. Here in pre-calc, I'm going to show you a couple of steps to help you come up with a sketch. In calculus, they're going to show you the final step to get a more perfect sketch. Still going to be a sketch, but more perfect. Okay? So, because in order for you to get a more perfect sketch, you need some calculus skills, which you're not there yet. Okay? Maybe you are. Maybe you're not. But just wait. Okay? One step at a time. Alright, so here's what you're going to do. The first tool that you're going to use is called the leading coefficient test. Okay? The leading coefficient test is going to tell you whether your graph is eventually going to fall or it's going to rise. Do you guys know what I mean by eventually it's going to rise or fall? Exactly. So as you're going to infinity or negative infinity, are you going to be going in one direction, like for example going up, or are you going to be going down? Okay? So that's what the leading coefficient test is going to help you figure out. Okay? Now, everything has to do with the function's degree and by the leading coefficient. Okay? So, here's the two scenarios that you can have. If your degree is odd, for example on A, your degree is 5, and the leading coefficient is positive, you're going to have a graph, and you can do a sketch to the side, that falls to the left, so it's going to go this direction, and rises to the right. What's happening in between, we'll talk about it in just a second. Okay, so right now we're just talking about what's happening. Another word for this is called end behavior. If you want to kind of put it in here, it's called end behavior. Okay, we're just talking about the end behavior. Alright, if your degree is odd, so look at example B, but your leading coefficient is negative, you're going to have an end behavior that rises to the left and falls to the right. And then there's going to be something happening in between, which we'll figure out here later on. Okay? Alright. Number 2, it says, if your degree is even, you have two scenarios. If the degree is even and the leading coefficient is positive, your end behavior is going to be rising left, rising right. And lastly, if your degree is even but your leading coefficient is negative, you're going to be falling left and falling to the right. Okay? You're going to be using that vocabulary, falling, rising. Okay? Don't say it goes up, it goes down. You're going to say rising or falling. Okay? Alright, so I gave you two problems there. Try them on your own. Find out what the end behavior is for each one of the given graphs. Alright, so for number 1, what you guys get? It falls to the left and it rises to the right because it is odd and it is positive. Okay? Number 2, what do we get? Falls left, falls right. Very good. Okay? Leading coefficient test. Relatively simple. Okay? Alright. So now, once you figure out what's happening at the end, or the end behavior, now you want to try to figure out what's happening in between. Okay? In order for us to figure out what's happening in between those end behaviors, we're going to have to deal with the zeros. Okay? Which you have been doing, but now we're going to be dealing with functions whose degrees are higher than 2. Okay? Alright, so it says, if a polynomial function has a degree n, obviously n would be the highest degree, okay? The function has at most, highlight that, at most n real zeros. It doesn't mean that it will have that amount of real zeros, okay? At most n real zeros. And also, it means that at most it has n minus 1 turning points, also known as relative maximums and relative minimum. Okay? Alright. Here in the box I've put real zeros of polynomial functions. If f is a polynomial function and a is a real number, the following statements are equivalent. Okay? X equals a is known as a 0. X equals a is also known as a solution. X minus a is known as a factor, and a comma 0 is an x-intercept. They all mean what? The exact same thing. Okay? So make sure you remember. So on the test, if I say solution, you know that I'm talking about a 0 or an x-intercept, correct? The one that I forgot to write down is also known as roots, correct? Okay, you should be able to remember or be familiar with all those, with that vocabulary. Okay, they all mean the exact same thing. Okay, so how do you find zeros? You've been doing this. Algebraically, you're going to set your equation equal to 0. Well, graphically, you can put it on the calculator and find out using the functions of 0. However, bad news for you, there will not be much of a calculator section on this upcoming test. So for this part, you're going to have to do everything algebraically. Okay? Test will be in 2 weeks, right before the end of this. Anyway, so you're going to set your equation equal to 0, negative 2x to the 4th power plus 2x squared equals to 0. Okay? Now, guys, so because your degree is 4, you might not be as familiar with what to do. However, does anyone know what I can do here to factor this thing out?
X squared.
They both have in common an x squared, and what else? 2. Would you like to get rid of the negative as well? Okay, so let's factor out a negative 2x squared. So that means negative 2x squared times what is going to give you negative 2x to the 4th power? And then negative 2x squared times what is going to give you positive 2x squared? Minus 1 equals to 0. You now have two factors that you can set equal to 0. So that means that negative 2x squared equals to 0. And x squared minus 1 equals to 0. Okay? This, when you simplify, means that x equals to 0. And this means that x equals plus or minus 1. Correct? Alright. In this section, you're going to be dealing with polynomials of higher degree, where you're going to be able to factor out a term from all of the terms. Okay? Does that make sense? You're going to be able to factor out from each term something. Bring it all the way out. On the upcoming lessons, that's not going to happen, and I'm going to show you how to work around that. Yes, sir? No. Okay, yes. So for today, something is going to factor out. Okay? So keep that in mind. I want you to try the next number 4. Find out what all the zeros are. Okay? Yes. Uh-huh. I'm going to talk about that here in just a second. But that's a very good observation. Alright. Alright, so for this one, you notice that they all have in common an x, correct? So you should have been able to factor in x. So this becomes x times x squared minus 12x plus 36 equals to 0. And then you should recognize that in parentheses now you have a quadratic, which you should be able to factor out. What does it factor out to? x minus 6 times x minus 6, correct? Which means that your zeros are what? X equals 0 and x equals 6, correct? Alright. I'm going to talk about something that I did not actually include in the notes, so write it down, okay? Notice how you only have 2 answers, and at most, how many answers were you expecting to get based on the degree? 3, correct? This degree tells you that you were expecting to get at most 3 answers. Now, in reality, you did get 3 answers, because 6 showed up twice, okay? I'm going to talk to you about something called multiplicity. So I'm going to talk about it right here. Multiplicity. Okay, I know. Anyways, so here's the concept of multiplicity. It is how many times a solution appears. Okay? That's the concept of multiplicity. How many times a solution appears? In this case, x equals 0 appeared 1 time, and x equals 6 appeared 2 times, correct? Now, but how is that going to help you? Well, multiplicity can actually help you with graphing. If your multiplicity is odd, you are crossing the x-axis. If your multiplicity is even, you are touching the x-axis. Okay? So what do I mean by odd and even? I'm not looking at the actual value because I'm looking at the amount of times that it appeared. For example, x equals 0 appeared once. The multiplicity is 1. 1 is an odd number, so that means that it is going to cross at that value. The multiplicity of 6, it happened 2 times. That's 2, which is even. It's going to just touch the x-axis. Okay? So what do I mean by all this? Okay, now you have all the tools to come up with a good sketch. Okay? We're going to try it with number 5. So number 5, here. Let's talk about end behavior first. It is degree of 3, and it is positive, so your end behavior is what? Falls left, and it rises to the right. Correct? Now we need to find the zeros. Okay, so we're going to set this equal to 0. 2x to the 3rd power minus 6x squared equals to 0. Okay? You should be able to recognize that you can factor out a 2x squared. So 2x squared times x gives you 2x to the 3rd power minus 3. Okay? Are we okay with that? Alright, so now we know that 2x squared equals to 0 and x minus 3 equals to 0, which means that x equals 0 and x equals 3. Okay? Now, let's talk about multiplicity. So, x equals 0. How many times did you get x equals 0? 2 times. It's even, okay? And how many times did you get x equals 3? You need. Here's what you're going to do. You're going to put your, here's 0, x equals 0, and x equals 3, 1, 2, 3. It's there. Okay, so you're going to plot those points. Your end behavior, according to you, you said that it was falling left and rising to the right, so I'm going to just draw an arrow going that way, draw an arrow going this way. Okay? Now, here's what you're going to do. You know that as you're going from left to right, your graph is going to begin to approach that point, correct? So you're going to begin to approach that point, and that's 0, right? How many times did it appear? Twice, which means that you are going to just touch the x-axis. So this is what I mean by touching. You're just going to get there, and you're going to turn back down. And you're going to do a smooth curve because it is a polynomial. Don't make it too concave. Now, you're going to turn, but now you're going to need to use your reasoning. You have to go through that point, which means that you're going to have to turn around, correct? So you're going to make a smooth curve, turn around. And how many times did x equals 3 appear? Once, which means you're going to cross. And now you're going to notice that it matches your end behavior, correct? Everything should match according to the information that you found. Okay? Now, your next question might be, for example, here, how do I know how much should I go down, or when should I turn? That's calculus. Okay? For now, you're just going to make a turn. Make sure that it's not sharp. Make sure that it's smooth. Okay? In calculus, we're going to show you where exactly is your relative maximums and your relative minimums. Okay? But for now, we're okay with just a sketch. Just make a turn. Make it smooth, turn, and make sure that your end behavior matches. Cool? Alright, so now that you've seen an example, try number 6, and we're almost done for the day. Alright, check your answer. It should look something like that. You found the zeros to be 0 and 3/2. The multiplicity of 0 was 1, so it crosses at 0, and the multiplicity of 3/2 was 2, so it just touches or bounces, if you want to think about it that way. At the left, rises to the right. Alright, which leads us to the last concept that I want to talk about in this section, which is called the intermediate value theorem. Okay? The intermediate value theorem. Alright, so here's what I want you to... The intermediate value theorem was something very... calculators, the intermediate value theorem has kind of become obsolete. Right? We don't really use it that much. I still want to share it with you because at that time it was pretty genius to think about it this way. Okay? The way they did it. Okay? But in other words, the intermediate value theorem states that... Let me read it first and then I'll explain it. It says that you're going to let A and B be real numbers such that A is less than B. If f is a polynomial function such that f of A does not equal f of B, then in the interval A to B, f takes on every value between f of A and f of B. What? Alright, so here's what this means. So I want you to draw a sketch. So we're going to pretend that you have the following function. We're just going to call that f of x. Okay? And we're going to... The important here is that A is less than B. Okay? Notice on this sketch, notice that the A is below the x-axis. F of A. There is a 0 somewhere in between that A value and that B value. F of A and F of B. So here's what they used to do back in when there was no calculators and you didn't have something that was pretty where you could factor it out or that it came nicely to find the zeros. They will use the intermediate value theorem to kind of figure out where those zeros would be. So they would say, okay, it's between A and B. Okay? But then they will go even further. So let's put actual values to A and B. Let's say it's between 2 and 3. Okay? And then they would say, okay, if it's between 2 and 3, is it between 2.1 and 2.2? Or is it between... That's your answer. Now...
Wow, that is so precise.
That's all you do. So here's what you're going to do. For number, say approximate the zeros. It doesn't say find the zeros. Approximate the zeros for this equation using your calculator. Go.
Wait, why would you want to approximate the zeros?
You're going to approximate where the zeros are located. The table. And I would just scroll down. So look. So notice how it's negative and then it becomes positive, which means you're going to have a 0 between what value and what value? 0 and 1. So there should be 1 between 0 and 1. And then if you keep scrolling, between what other value? 6 and 7. And if you keep going, you will find that there is 1 between 11 and 12. Okay. I would also look at the graph because what if that... And then use the table to figure out where, between what two values it would be located. Okay? Alright, so that's the intermediate value theorem. Homework. I forgot.